Hello students, welcome. Previously, Form 1, Topic 3, Lesson 1, we have done the introduction part of the chemistry of acids, bases and indicators. So today, Lesson 2, we are going to proceed to the third category or type of indicators, which is the universal indicators. So we're saying universal indicator is a mixture of several indicators. It exhibits a range of colors in acids and in bases depending on the strength of the solution. Learners, remember when we are dealing with the commercial indicators were only telling us that the solution is either acidic or basic or neutral. But when we're talking about universal indicators, apart from being the solution acidic, basic or neutral, it will also tell us the strength of the acid and the bases. For example, we're having a strong acid, weak acid. We're having a strong base, weak base. And that one, we are going to use the pH scale. So I say next, the strength of an acid is called acidity, and that of a base is called alkalinity or basicity. So next, pH scale is the degree of acidity or alkalinity of a solution or a substance. This is how the pH value look like. It has a pH value ranging from 0 all the way to 14, and in the center we're having a pH of 7, which represents for neutral substances, the pH value for neutral substances. So next we are saying pH value ranges from 0 to 14, the way we have said. Then next we are saying the pH values of acids range from 0 to values just less than 7. So you have to know that the pH value for acids range from 0 to values just below 7, not 7, below 7. The ones that are less than 7 will be acids. So how will I know the pH value for strong acids? We are saying strong acids have pH values which range between 0 to 4. That means the ones that are very far from 7 are regarded to be strong. So if you want to know strong acids, so the pH value will range from 0 to 4. What are examples of strong acids? They include hydrochloric acid, sulfuric acid, and nitric acids. Those are examples of strong acids. So what about weak acids? We're saying weak acids have pH values which range between 4 to 7. How will you know if a solution is weak? It has to be near to 7. Next, examples of weak acids include lemon juice, we're having ethanoic acid, carbonic acid, we're having benzoic acid, we're having oxalic acid. All of those acids are weak acids. So we are told here not. The lower the pH value, the more the acidic the solution is. What does that mean? For example, you can be given a table where we have solutions and also pH value. Then those solutions can be A, B, C, and they're having their corresponding pH value. So in case if you get like 2 pH values for acids, and one is maybe a pH value of 1 and the other one is a pH value of 3. So you see, both 1 and 3 are pH values for strong acids. But which one is stronger? You have to consider that. That's why we're saying here, the lower the pH value, the more the acidic the solution is. So that means the strongest acid or the strongest solution, the strongest acidic solution in that case will be for the pH value of 1. Because 1 and 3, 1 is lower. That's why we're saying here, the lower the pH value, the more the acid the solution is. So next we are saying the pH values for bases range between 7 and 14. So that means above 7 up to 14 will be the pH values for bases. Next, we are saying weak bases have pH values which range between 7 to 10, above 7 to 10. So what are examples of weak bases? They include antacid tablet solution, ammonia solution, calcium hydroxide solution, and magnesium hydroxide solution. The next, strong bases have pH values which range between 10 to 14, above 10 to 14. So we are saying examples of strong bases include soap solution, wood ash solution, sodium hydroxide, and potassium hydroxide. Those are examples of strong bases. So we say note, the higher the pH value, the more the alkalinity the solution is. For example, if we are having two solutions that we know that they are bases, like for example they're having a pH of maybe 12 and a pH of 14, we know both of them they are for strong bases. So which one is strongest now in that scenario? It will be the one with the pH of 14, because we're saying the higher the pH value, the more the alkalinity the solution is. So let's proceed to examples. Number 1. We are told the table below shows the pH value for some unknown solutions. We're having solutions here for this column, and we have pH value for this column. So part A of the question, we are told which of the pH value represents. We are talking about pH values. We have not been told which of the solutions. So you have to know that. Roman 1, a weak acid. So when we check, we said acids, they are having a pH from 0 to below 7. So from 0 to 7, we're having 2 and 5. So 2 and 5, which one is closer to 7? The one that's closer to 7 will be the one that's for weak acid. So we're going to have 5.0. So our answer here is 5.0. So next, a weak base. So bases, we said they are from above 7 to 14. So that means above 7 to 14, we're having 8 and 13. So which one will be for weak base? We say the ones that are weak, they will be closer to a pH of 7. So that means between 8 and 13, 8 is nearer to 7. So that's why we're going to say our answer is 8.0. So we proceed to Roman 3, a strong acid. So strong acid, the way we say the acids are these two, A and B. So 2.0 will be very far from a pH of 7, so it will be for a strong acids. Remember, we say strong acids, they are going to have a pH value of 0 to around 4 there. So we're going to say 2.0. Then Roman 4, we are told strong base. So bases, the way we say, they are going to have above 7 to 14. So above 7 to 14, we are having E and E. So which one is for strong base? It will be 13. That's for solution E. So we're going to say 13.0 as our answer. 13.0. So next, let's proceed to part B of our question. We are told what will be the color of litmus solution in solution Roman 1 D, Roman 2 B. So what is D? What's the nature of D? So D, we're having a 8.0. So is it acid or is it base or is it neutral? You have to know that. So it is base, because we said the pH value for bases are above 7 up to 14. So 8 is in between there. So that means it's a base. So what is the effect of litmus solution to a base? So we're going to have blue. The color will be blue. So what about Roman 2? Here we're having B. And we check B is 5.0. And 5.0 is for acids, because we said the pH value for acids range from 0 to below 7. So 5.0 is there. So what will be the effect of litmus solution to an acid? So it will be red. The color will be red. So we're done example 1. We proceed to example 2. So example 2, we are told the pH values of solutions A, B, C, and D are shown in the table below. The way we see here, solution A, B, C, D, and these are their pH values. So I say the 4 solutions were sodium hydroxide solution, ethanoic acid solution, sulfuric acid solution, and ammonium hydroxide solution. So we are told to complete the table by naming the solution corresponding to solutions A, B, C, and D. So let's start with sodium hydroxide. Sodium hydroxide is a base, so it is a strong base. So when we check the bases here, it will be A and also D, because check the pH values, they are more than 7 to, they are above 7 to 14. So that means 9.7 and 12.0 are in that range. So that means which one is stronger again? Because sodium hydroxide is a strong base, or an example of a strong base. So it will be for solution D. So we are going to write here sodium hydroxide, the way it is written, NaOH, sodium hydroxide. Then we proceed to the second solution. It's called ethanoic acid. So ethanoic acid is an acid. Then is it a strong acid or weak acid? So it's a weak acid. So let's check the pH values for acids. It is B and C. So which one is for weak acid? It's 5.3. So we're going to write ethanoic acid the way it's written there here. CH3COOH. Then we proceed to sulfuric 6 acid. Sulfuric 6 acid is also an acid, so it's a strong acid. And we said a strong acid will be for 2.1, so we're going to write sulfuric 6 acid, the H2SO4. So we proceed with the ammonium hydroxide. That's a base and it's a weak base, so we're going to put in the solution A there. So we're going to write ammonium hydroxide the way it's written there. So we are done with that example number 2. We are going to proceed to example number 3. So in example 3, we are told the table below shows the pH value for solutions A, B, C, D, and E. The way you see, we have this column for solutions and here for pH values. So we are told which solution is likely to be aqueous ammonia. So what's aqueous ammonia? It's a base. So is it a strong base or weak base? It's a weak base. So let's check for the pH values of the weak base here. So we have 9.8. 9.8 is a base. Then we're having here 12.0, another base. So 9.8 is a weak base, because we said the pH value for weak bases will be from above 7 up to 10 there. So we're going to have the solution as E. So we're going to write here solution E. So we proceed next. We are told sodium hydroxide. Sodium hydroxide is also a base, but it's a strong base. So strong base will be for this 12.0. So the solution will be solution B. So we proceed. Roman C, distilled water. Distilled water is a neutral substance. So you say neutral substance have a pH value of 7. So the solution is D. So we're having here D. Next, but D, we're having hydrochloric acid. Hydrochloric acid is a strong acid. So strong acids are having a pH value of 1, 2, 3 there up to 4 there. So we're having here C, because A is 5.2. So that's a weak acid. So we're going to say C here. So next, let's proceed to example number 4. We are told complete the table below. In this table, we're having substances, pH value, and also the nature of the substances. So here we're supposed to complete the table. So here we're having sodium hydroxide. It's a base, pH value of 14. So what is the nature of this substance or this solution? It will be strongly basic. So that's how we're supposed to write it. Strongly basic. Strongly basic or alkaline. That's what we can say. So you are supposed to fill it like that. Then next, we're having here pure water. Pure water is a neutral substance. That's the nature. So the pH value is 7. So we say the pH of 7 is for neutral substances. Next, we're having soy milk. Soy milk is having a pH of 5. So that means it is an acid. So its nature will be weakly acidic. So yes, you have to write like that. Weakly acidic. Weakly acidic. That's the nature. Then next, we are going to proceed to wood ash. Wood ash is an example of a base with a pH value of 10. So that's weakly basic. We are supposed to write there. Then we're having dilute hydrochloric acid, the pH value of 1. So the nature will be strongly acidic. We're having next baking powder with a pH value of 9. So baking powder is a base with a pH of 9. So it will be weakly alkaline or weakly basic. Then lastly, dilute sulfuric acid with a pH of 1. Then we are going to write here strongly acidic. That's the nature of that substance. Next, we are going to proceed to the extended questions. Learners, we're having question number 1. The way you see, we proceed to question number 2. This is question number 2 in the extended question. Learners, that's the end of our class for today. Thank you for watching.